Meteorite falls can be spooky, as residents of several areas on the planet over recent years have seen, as detonating meteorites have blown out windows and caused widespread damage. And while recovered meteorites offer a wealth of information about the solar system, and even alien geology, and even offer the prospect of an interstellar origin from another star system entirely, they also may have been instrumental in the abiogenesis of life, and even its transfer between planets. But one problem that always comes up in the study of meteorites is trying to pin down what asteroid, if it even still exists, or other body they originate from. But we do know the answer in a number of cases, and they show just how varied and outright weird this star system can be. So here are 10 meteorites, meteorite types, or something even stranger, and where they may have come from. Number 10. Milb, Western Australia, October 1960. Origin: Vesta. About 1 p.m. in the afternoon on an October day in 1960, none of the witnesses could remember what specific day it was, near a remote cattle station in Western Australia, an object was spotted with sparks streaming off it by 2 station workers, while they were opening a gate seemingly headed for a plain located to the north. At the time, no search for any stones was initiated, until a decade later, in 1970, when locals found 2 stones. Many thousands of fragments of this meteorite have since been recovered by people in the area, and are readily available on the market as relatively fresh-looking stones. The meteorite is a special type of meteorite that is highly altered. This meteorite is basically a lava rock, and would have formed in early subsurface volcanic activity on the asteroid it originates from. We know which asteroid this is with fairly high confidence: Vesta. 4 Vesta is the second most massive asteroid in the asteroid belt, beat out only by Ceres. And up until relatively recently, all that was really known was that the spectrum of Milb, a type of meteorite known as an chondrite, and many of its like meteorites found worldwide matched Vesta. But then we learned far more. In 2011, NASA's Dawn spacecraft circled Vesta and studied it extensively, finding out that Vesta is large enough to almost be a dwarf planet, and that lended itself to create a very different asteroid than most in the main belt. It turns out Vesta is one of the very few asteroids that actually is differentiated out into a crust, mantle, and nickel-iron core like a planet, instead of just being a conglomeration of loose, very primitive rocks like many asteroids. How this happened was unusual, so Vesta appears to have formed very early in the history of the solar system, basically 1 to 2 million years after it all began. At the time, there were still a lot of radioactive materials in the young star system that were incorporated into bodies forming during this time, and that raised the amount of radioactive decay, producing sufficient heat to melt Vesta and allow it to differentiate out like a planet. But the story of the Vesta meteorites doesn't end with the chondrites like Milb. There are other types associated with this asteroid. So the question is, why so many? This is unknown. Number 9. Nordlingerite, Germany, 15 million years ago. Origin: Earth. Tektites are a natural glass found in certain areas of the world, sometimes very attractive, that have been known for thousands of years. And while not strictly an extraterrestrial rock, they are certainly related to one, because the tektites are now believed to be an impact glass. Large fields of these tektites can be found in Europe, Asia, Australia, and so on, and there are many different types, some showing very clear aerodynamic evidence of having flown through the air in a molten state. You might first wonder about volcanoes, but it doesn't work. Yes, volcanoes produce glasses, but not like this, and the strewn fields are often not near any volcanic areas extinct or active. We do not see volcanoes producing them now, and the fields are so large that a volcano, even a supervolcano, can't do it, but an asteroid impact can. So this specific entry will focus on one of the prettiest of the tektites, the moldavites, which are a beautiful translucent green color and are often made into jewelry. They are associated with the Nordlingerite impact crater in Germany, but are spread widely around Central Europe in general, especially the Czech Republic. The Bavarian city of Nordlingen actually lies within the remnants of this crater. It's thought that 15 million years ago, what was very likely an asteroid smacked into what would become Germany. Weirdly, there is a second impact crater about 26 miles away that was initially thought to be related, but it turns out it isn't. It's a separate instance of Germany getting hit about 500,000 years later. The impact hit a sand deposit, which is where the tektite glass originates from. And the distribution of the tektites seems to suggest that the asteroid came in from the west-southwest. Tektites are now known to be impact melt, but mysteries remain. For one, they are strangely devoid of water, which led some early meteoritic pioneers to suggest that they might actually be impact ejecta blasted off the moon, though this is no longer suspected, especially since many of the fields are now associated with known Earth craters. So the origin point for these is Earth, but with a strange story. Number 8. Sebka El Mela 001, Mali, 2022. Origin, perhaps Mercury. Found by meteorite hunters in Mali in 2022, this meteorite is of a highly enigmatic type of meteorite called an aubrite. Some of these rocks are very strange. I know of one that fell in Kansas that is almost pure white and not like any other type of rock I've ever seen. This new aubrite find from Mali is equally strange in that a single olivine grain found in a mounted slice of this meteorite was found to actually very slightly predate the solar system's full formation. That's puzzling, and the consensus still is, on this volcanically altered type of rock, often a jumbled mess of rocks, being from some kind of partly molten asteroid in the very early solar system. But more recent work has cast a slight amount of doubt on that, and it may help solve a long-standing mystery. The new idea floating around is that the aubrites may have originated on Mercury. The reason for this is that it's always been noted that aubrites tend to be light in color, even white, and often have a certain lunar look to them. They look like something that might form on the moon, at least superficially, but the chemistry and isotopes are all wrong for the moon. While a volcanic asteroid might fit, it's possible that Mercury might fit better, being in some ways a bit similar to the moon. It's also covered in craters, so material was getting blasted off. But it was uncertain just what meteorites in the collections could be connected with Mercury. There were only a few candidates. Mercury is a planet, and planets alter their rocks, and most meteorites remain relatively unaltered, other than pressure and shock from the beginning of the solar system. In short, asteroids get altered, often compacted geology, because they smack into each other. It remains to be seen whether the aubrites actually do originate from Mercury, but it would help to answer the mystery of where the rocks from Mercury are. At the same time, the asteroid 3103 Eager also seems to fit the bill for the aubrites as well. Either way, it's likely we will soon know which is the origin for these enigmatic stones. Number 7. Say al-Uhemir 169, Sultanate of Oman, January 2002. Origin, the moon. You'd think for the amount of craters there are on the moon, we would find chunks of the moon all over Earth. We actually do not. Lunar meteorites remain rare, though we do find them. What's interesting about the moon is that we have a large amount of samples of lunar rocks and soil collected so far by NASA's Apollo missions. The Soviet Union returned samples, and more recently China. As an aside, these rocks are a real problem for the moon landing hoax conspiracy theory. It remains popular on the internet because all of these rocks are actually consistent with each other. The Soviet and Chinese samples are geologically consistent with the Apollo samples, and they are also consistent with all of the privately held lunar meteorites and finds that have come in from all over the world. None of them are consistent with any rock on Earth, however. Lunar and Earth geology have a ton of differences, but what does happen to the meteorites is weather and contamination from Earth's environment. It's difficult to find a meteorite that hasn't been rained on, unless it was immediately picked up after falling. So the Earth recoveries are often weathered, but the return samples are not. You're not going to get the Americans, Soviets, and Chinese to agree to a conspiracy theory to hide the origin of a bunch of rocks, one type of which you can go walk around the Sahara, find yourself, break into smithereens, and sell them on eBay. You can buy a moon rock, and any geologist will tell you that it's not from these parts. In any case, while we can pin a lunar origin on these meteorites, what isn't often possible to determine is just where on the moon they came from. But there is one possibility. Found in 2002 in Oman, the Say al-Uhamir 169 meteorite is lunar, but it has an interesting composition in that it is an impact melt breccia, and it's really unusually high in thorium, rare earth elements, phosphorus, and even uranium. It's a very interesting rock if founding a lunar colony is on your agenda. That said, this rock had one heck of a ride. This meteorite's isotopes indicate that it actually went through 4 separate impact events. The first 3.9 billion years ago, the second 2.7 billion years ago, a third 200 million years ago, and then it was finally launched into space less than around 340,000 years or so ago, only to fall on Earth just under 10,000 years ago. That complex history actually allowed geologists to suggest that the Lalande impact crater, or its general vicinity, was the likely origin point for this strange meteorite. Number 6. Vakam Mora, Chile, 1861. Origin? Psyche? This is a tale of a very strange asteroid and a very strange meteorite, and the two may be related. In 1861, prospectors exploring a very remote area of Chile's Atacama Desert came across strange rocks that seemed to be composed of roughly 1/2 metal and 1/2 stone. Subsequently found to be a meteorite, this very metal-rich type of meteorite is known as a mesosiderite and might have come from a parent body that was particularly heavy with iron and nickel in its makeup. And then we have the asteroid 16 Psyche, which in some ways looks like a giant mesosiderite. So much so that it was put at the forefront of asteroids to visit by NASA. A mission is on the way to this asteroid, known as the Psyche mission, to explore why this asteroid is so different from most others and what its history is. But that mission, which should arrive at the asteroid around 2029, may well prove or disprove that this asteroid is the origin point of the mesosiderite class of meteorites, such as Vakam Mora, and yes, that's Spanish for dead cow. I'm guessing someone found one there at some point, but it's not for certain yet. There are other parent body candidates for the mesosiderites, specifically the Maria type of asteroid. So only time will tell, but there is a further mystery in this class of meteorite. This time it was found around the city of Chinguetti in Mauritania in 1916. The story goes like this. A French consular official, Captain Gaston Repère, claims he was taken blindfolded by a local chieftain on a 12-hour camel ride southeast of Chinguetti out in the desert. When the blindfold was removed, Repère said he saw a gigantic iron-rich mountain, 130 feet high and 330 feet long. He collected a 4-kilogram chunk, which found its way to Paris and was tested a number of years later and found to apparently be a mesosiderite, opening the possibility of a giant meteorite sitting out in the desert in Mauritania. If this actually exists, it's never been found again. The general consensus is that Repère found a sandstone or similar hill and just happened to pick up the meteorite sitting on it, and the whole thing was a mistake. Professor Theodore Monod actually spoke to Repère in 1934 and mounted a search, and didn't find anything other than a sedimentary rock hill that he thought might have been what Repère saw. But in 1980, a water survey aircraft saw a strange semicircular formation directly to the southeast of Chinguetti. Professor Monod, however, could not find this feature. More recent analysis suggests that the original meteorite probably wasn't any larger than 31 inches in radius, but the mystery of the Iron Mountain still remains open. Lost pieces of Psyche, indeed. Number 5. Unknown, may or may not exist. Source: Venus. One of the great debates in meteoritics is whether you could actually have a meteorite out there somewhere with an origin on the planet Venus. Part of the problem is that getting a rock off Venus today in an impact would be exceedingly hard. That 93 bar atmosphere is going to be absolutely punishing on a rock traveling at escape velocity, to the point that nothing may make it to space. That said, Venus wasn't always like it is today, and there may have been a friendlier time for meteorites, known as Cytherean meteorites, an old word linked to Venus, to have made it to space. What is clear is that enough is known that the cosmochemists believe they can identify a meteorite from Venus should one ever turn up. Should we ever see one, it's likely to be volcanic, from what we know about Venus, and will probably not have ventured further than the inner solar system in its history. It would be interesting to see for sure, because volcanic meteorites can trap gases from the atmosphere of their planet of origin. We see that with Mars, and Venus in that regard would be blatantly obvious, and depending on when it left Venus, inherently interesting, because it could show a very different atmosphere than what Venus has now. Number 4. La Paz Ice Field, Antarctica, 2002 season. Origin, an unknown comet. Antarctica serves as a meteorite collection point. Basically, it's a huge conveyor belt that slowly moves all the meteorites falling on the ice to areas where the ice melts and conveniently deposits meteorites for scientists to retrieve. And indeed, in many places in Antarctica, if you see a rock on the ice, it's probably a meteorite. One such meteorite was recovered at the La Paz Ice Field in 2002, and is known as La Paz Ice Field 02342. Whatever this meteorite is from, it appears to have once been hit by a comet. It's a type of very, very primitive meteorite, known as a carbonaceous chondrite, that date from the very beginning of the solar system, 4.5 billion years ago. By their nature, they contain carbon, a major building block of life, and some have even been found to contain amino acids, again related, but not solely made by life. Whatever it was probably from beyond the orbit of Jupiter and could have fallen in Antarctica any time over the last few thousand years. Inside of this meteorite, scientists found a fragment of a very carbon-rich form of primitive material that looks to have once been part of a comet, or at least some kind of proto-comet, in the outer solar system. What might possibly have happened is that the particle material that the outer solar system and Kuiper Belt objects formed from migrated inward due to drag caused by gas in the solar nebula, delivering and embedding the fragment in this meteorite somewhere out beyond Jupiter, and something, probably an impact, sent it our way, giving us a tiny window into the early history of the outer solar system. Number 3. Indark, Azerbaijan, 1891. Origin inside the orbit of Mercury. This meteorite is part of an enigmatic and rare class that composes less than 2% of stony meteorites. Indark was observed to fall at about 8:10 p.m., April 7, 1891, in Azerbaijan. The stone, which is just a single rock, 27 kilograms, buried itself in the soil about 18 centimeters deep. The makeup of this particular meteorite and its class is strange, alien in many ways to anything from Earth. Indark contains weird minerals like oldamite and weird sulfides, nitrides, and others that are only ever very rarely found on Earth, if ever for some of them. It's metal rich, but this class is oxygen poor, so has little in the way of iron oxide. There are also tiny deposits of pre-solar minerals in this meteorite that are really something more associated with red giant stars and supernovae, something very important to the formation of the solar system, than what we usually see in the solar system, including nanodiamonds, spinels, nearite, all in unusual forms. But that's where it gets weird. When they look at the isotopes of this class of meteorite, they actually look strangely similar to Earth, unlike their geology. It's almost like these types of meteorites were contributing strongly to the formation of Earth somehow, and originated somewhere relatively close by. The weird thing here is that these meteorites were formerly thought to be the driest rocks in the solar system, but actually contain a significant enough amount of hydrogen to have been major contributors to Earth's water supply. And they are also a candidate for how Earth got so much nitrogen in its atmosphere. As to where they originate, the current thinking is that these meteorites formed in the very inner solar system, perhaps within the orbit of Mercury, and are very early meteorites. It's worth noting here another meteorite mystery regarding parent bodies. Studies have shown that our meteorite collections only show about 150 to 200 possible parent bodies out of many thousands of asteroids. No one knows why this is, but it's a problem because it makes a sampling bias evident. For some reason, we only see meteorites from some asteroids, but apparently not others. Number 2. Somewhere in Northwest Africa, 2008. Origin, possibly Theia. This meteorite is known as NWA for Northwest Africa, and the number 5404 being the 5400th meteorite to surface from somewhere in North Africa in the Sahara. The locations for these meteorites often aren't written down, and are sometimes retrieved by Bedouin and foreign meteorite hunters so far from a populated area with a name on it out in the Sahara that it would be frivolous to name them after a location hundreds of kilometers from anywhere, so they get numbers. This ranks as one of the most isotopically weird meteorites ever found, because wherever it came from, it was close to where the Earth and Moon formed. So close that one potential origin for this meteorite that's been floated is that it was knocked off Theia, the Mars-sized object that smacked into Proto-Earth and ultimately formed the Moon, which is roughly made up of about 1/2 each of both bodies, sometime before the impact. While not confirmed, this meteorite most closely resembles a type called a braconite, but not so closely to say it is one. It's simply anomalous, and unlike any other so far found on planet Earth. If it is part of Theia, though, it's among the most important meteorites we've found. Only time and more study will shed light on it. Number 1. Allen Hills 84001, Antarctica, December 27th, 1984. Origin, Mars. There are a number of meteorites in the world's collections that can be traced to an origin on Mars, often rocks of a volcanic nature. These rocks often contain tiny bubbles inside the matrix that is basically trapped Martian atmosphere, and the composition matches the rocks we measure with the Mars rovers. Confidence is very high that's where these come from. One of them, however, has proven especially enigmatic because it may have an astrobiological connection. Allen Hills 84001 was collected by scientists in 1984 and caused much controversy in the 1990s when work was announced that seemed to report anomalous structures that looked something like evidence of life, contained in minute veins of clay that have been deposited in the meteorite while it was still on Mars. There were several of these, including magnetic particles usually associated with microbial life on Earth, and even structures that looked like fossilized bacteria. The problem was that these structures were orders of magnitude smaller than a microbe here on Earth, calling the whole thing into question, and a low-level debate about it continues to this day. At the same time, however, there have been hypotheses in the biological world about Earth life that we have so far not detected, and also viruses that function on much smaller scales than what we can currently detect. And there doesn't seem to be a physical reason why it can't happen, we just haven't seen it. This led to a rather odd situation where the only organization to ever announce the discovery of alien life in the universe was NASA, twice. One for the Viking labeled release experiment and the other for Allen Hills 84001. And both were called into question, and the debate about both continues to this day. That is the reason why NASA got a bit gun-shy about announcing discoveries of alien life too early. Thanks for listening. I am futurist and science fiction author John Michael Godier, currently tossing out another factoid I found when researching the entry on Nordlingen in Germany. So the buildings there that are fashioned out of locally quarried stone actually contain a high proportion of very tiny diamonds that apparently formed from the shock of the asteroid impact. So if you ever visit there, eye the walls suspiciously, as I would, for no particular reason other than those wealthy rocks hid that secret for centuries. Not good, and be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.